Hi everyone, welcome you all in another session of AI/ML. Today we are going to start our new module. So this module basically takes it forward for the unsupervised learning. So in details we will be understanding what is unsupervised learning, and eventually we'll go ahead and see the some of the unsupervised learning models that we can just take it over, and based on that we have to understand that and we can train our model accordingly. Okay, so let's just take it one by one. So let me just share my screen first. Yeah, hopefully my screen is all visible to you. So learning actually means getting better by the experience that we are gaining, right? So when a teachers actually tell us the answer, like what is the answer that is there, so it is actually the guided learning, right? And when no one actually tells you the answer, you find a pattern like in the data by yourself, right? So that is actually the unguided learning. So of course, unsupervised learning is equal to the learning without any labels or answer. So that is the unguided learning. Okay. So that is basic, like in a basic sense, the knowledge about unsupervised learning. Okay. Now let's take an example. So imagine that you have a big box of toy that contains cars, dolls, again, then different balls. Then it contains blocks. Okay. So no one actually tells you which toy is what, right? You start by grouping them yourself. All cards together, all dolls together, all balls together. This is actually unsupervised learning. Okay. So of course you know about data. Data is information. Suppose you have an example, like examples of data, maybe the height of students, marks the student has gained in the exam, text, colors of fruits, shape of the object, all of it, right? So the the system or the computer or your model actually understands the numbers. So you give them the data like about like apple with like the object being apple with the height of the object being suppose 7, and the weight of the object is 150. You are not specifying like under which measuring unit you have measured it, because that won't be understandable by the system, right? Now coming down to the label versus unlabeled data. So we have already discussed about label data in supervised learning. So label data is basically the supervised learning when we have the idea, like let's give an example. For supervised learning, suppose we have the data set as fruits. Okay, just a moment. Fruit, and you have, suppose, is it sweet or not? Okay. Now here, suppose you have the fruit as apple, so it would be mentioned that yes. Next you have the fruit as lemon, and you the sweetness is of course no, there is no sweetness. So this is actually the label data. So for any of the fruit we are getting an answer that is it sweet or not, right? Now coming down to unlabeled data. Unlabeled data, that is coming under the unsupervised category. So for this, suppose we have fruit. Next, we have the sugar. Then we have, suppose, the size. Here, fruit is, suppose, apple. Here, the sugar level is, suppose, 7. The size is 6. Again, coming down here as lemon. Here, sugar is 2. Lemon is, size is 5. Okay, so this is the major difference. If you want to understand, this is the major difference between labeled and unlabeled data. So here you are getting a correct answer over it. Like if it is sweet, like for apple, yes, it is sweet. Lemon, no, it is not sweet. It is a sour in taste. That idea you are not getting, but we are getting the idea that it is not sweet, right? So, but here you can see in case of supervised, the label data actually helps us like classifying the data. Now here we have the unlabeled data, that is basically the unsupervised learning. Here we have the fruit, like the three different features, basically the fruit, sugar, and the size. The fruit being apple, sugar is 7, and the size is 6. Like the what is the sugar contained in apple, like that. So they would be the simple sugar, like glucose or fructose, like that. Coming down to lemon, it is 2. That is the quantity of sugar is not that much, and the size is 5. So my model must figure out everything by itself, like higher number of sugar contained. That means the apple itself is sweet in taste, and lemon having 2 in number of sugar. That means that lemon is not that sweet. Okay, this finding my system or my model has to make by itself, like need to figure out by itself. Okay, now here comes the reason why suppose you might be having the question, why do we need the supervised learning, right? So here basically the labels are missing, right? And we have like labels are too expensive in this case and the data is huge. So we are saying that my system actually explores and tell me what we have find, because in certain case when we are dealing with some of the data, giving a proper label is not possible, right? The labels are not possible. Sometimes maybe the labels are not there, or maybe the as I mentioned, the labels are too expensive to be taken accordingly, or the data is too huge that you we cannot consider the labels. In that scenario, we need to take an idea from the unsupervised learning. Okay. So, what can unsupervised learning do? What is the criteria? What exactly it do? Okay. So, majorly what it does, it actually find the group. Okay, like the similar items and form a group. Find groups. Okay, coming down, like basically it groups similar student, like grouping similar student, grouping similar customer. That is the work of unsupervised learning. Next is to find the hidden patterns. Okay, find the hidden patterns, like who buys what, next which things look alike. This kind of pattern they are actually finding. And the third is using this actually reduces more of our confusion. Like if we are having a bigger data, so in that case, like forming the labels would be too difficult. Then, in that case, we totally rely on the system, that the system will understand the pattern by itself and try to figure out the stuff. Okay, so that is, it reduces the confusion. Okay, these are the major tasks of unsupervised learning. Now we have to discuss two big type of unsupervised learning. Okay, types of unsupervised learning. The very first one is clustering. And the second one is dimensionality reduction. Okay. So basically, what happens in case of clustering? Clustering is like making groups of similar things. Okay. Clustering is like making groups of similar things. Okay. So basically, what happened? Grouping a different animal based on their structure and all come under clustering. Okay. And then we have the dimensionality reduction. Dimensionality reduction actually makes the data simpler. Suppose my data set is too huge. So I want to make my data set simpler without losing any of the important information or without losing the meaning of it. Okay. So suppose I have suppose 10 features in my data set. And from 10 features, it will just shrink it down to two important features. Like suppose in my data set, I have the SL number. I have the other criteria that is not exactly like going across, like not giving that much of importance, right? So in that case, I like my features that is there initially as 10 that has been like dropped to two important features. Like it has been done without losing any important part of it, like any important information from that data. Okay. Now coming down, like what is similarity? Similarity means how close the things are. Okay. Suppose I have a fruit. For that fruit, the height is 150 centimeters. Okay. I have another fruit whose height is suppose like it's way too long. I understand. Like let's consider not a fruit. Let's consider a person with a student maybe. Like this name of the student is S1 is 150 centimeter and height of another student like S2 is again suppose 152 centimeter. Okay, so you can understand the heights are very similar. No much gap is there between them, right? And suppose I have another, like comparing it with, like suppose the height of student S1. Okay, just a moment. S1 is 150 centimeter. Okay, and I am comparing it with height of the student, suppose S3, and the height of that very student is suppose 190 centimeter, right? So we can understand from this two example, S1 and S2 are similar, but S1 and S3 are not similar. S1 and S2, of course, they are similar, and S1 and S3 are not similar. Okay, so this is the major idea about similarity. Hope you understood. Now I need to make you understand about the distance. How, why, and in what reason we are understanding this. We will be discussing accordingly in the later section. But this terminology you need to keep in mind and also need to understand it because in the later algorithms and while proceeding with it, we will be needing it like in every second. Okay, so you need to make this clear and make this understand, like you need to understand it in a proper way. Now coming down to the next is distance. Okay. So distance, like imagine suppose we have the number that is going from 0 to 5 Next, it's going from 5 to 10. Next, going from 10 to 15. Okay. So now the distance between 5 and 10 I want to find. Okay. So the distance between 5 and 10. Right? So what we will be doing, we will be simply subtracting 10 minus 5. So that would be giving us the result as 5, right? So the distance between 5 and 10 is coming down 5. So smaller distance, that signifies more similarity we will be getting. Bigger the distance, we will be getting the lesser similarity. Like here you can understand, like if I am doing like here, from S1 and S2, we found it similar, right? Because the height is 150 and 152 are very much similar. Like now, let's take the difference of them, right? So, of course, we will be getting like from this, the difference is 2 only, 2 centimeter only, right? But if I need to do this, like subtract this to this, like I am subtracting 190 minus 150. Right? So, of course, what is the difference? We are getting a difference of 40 centimeters, right? We are getting a difference of 40 centimeters. So, as we can understand, like when two or like when the distance would be lesser, then we will be getting more similar items. If the distance become larger, we will be getting the less similarity among the items. Okay. So now I want to understand about suppose distance in real data. Okay. Suppose I am taking student A with a height that is coming down as 150 and weight that is coming down to be 50. Okay. This is for student A. Now I have a student B for them as well. For them, the height is suppose changing to 152 and the weight is changing to 52. Okay, now I need to find out the distance. Then how we will be using? So we will be here using the Euclidean distance the same way how we have used it in case of KNN. In the last session, we have discussed about KNN model for classification. There we have find out the distance between the 2 points. For that, we have used the Euclidean distance. So here also we will be doing the same. Okay. So here basically we need to find out 152 minus 150 and we need to do the square of it. Okay, just a moment. The square of it plus we need to do the 52 that is the weight minus 50 and then we need to do the square of it again and then finally just a moment. Yes. Then finally, we need to, what happened? Just a moment. Yeah. Okay, let's just write it here, the distance. And here we basically need to do the square root of it. That is to the power half. Okay, so that we basically need to do. So if I am continuing with the calculation up here, like let's continue with that part. So for that, how it is coming up, it is 152 minus 150. That is coming out 2. The square of 2 is coming out as 4. And again, we are doing the square, like the 52 minus 50, again 2, and the square of 2 is 4. So it is coming out as 8, and the square root of 8 that we need to do. The square root of 8 would be the result. Okay. So this is the basic idea about how to find out the distance. Okay. Now coming down, what is clustering? We need to understand what is clustering. Clustering, what basically we mean by clustering is like putting similar things into the same group. Okay. Suppose I have got a bag that contains red balls and blue balls. So, what I am likely to do, I will be putting the red balls together and I'll be keeping the blue balls together. That is the thing we are doing. So, that is like the clustering. Like we are putting the similar things together in the same group. Okay. Now, how like my model understands it? So my model decide how many groups to be formed and who belongs where. Based on that, we are going and forming the different cluster groups. Okay. So now we need to understand where this clustering actually works. Okay. Before that, let me just write it down. What clustering is. Clustering is like putting similar things together in a group, in a same group. Okay, so this is the meaning of clustering. Okay, so here basically we have taken it down like that. Here basically it has taken like that, like distance. Okay, fine. So now it will be staying like that, no issues. Now, majorly what we need to do here, as we are discussing about clustering, we need to understand where clustering is actually used in real life, right? So we are well aware of the shopping apps, like the e-commerce apps, that is where we are finding the similar customer group together or similar product group together. So suppose you are buying a product, okay? So you get a recommendation that this products are often brought together. So how you are getting this recommendation? First, all of the similar products that are going accordingly, that has been grouped, right? So that is first place a kind of recommendation, and then the part from where the recommendation is coming, that comes under clustering. Okay, and also the shopping apps put the similar customer group together so that the similar kind of recommendation can be given to them. Okay, so coming down to music app, so similar songs are often grouped together. You may see like the sad songs. We get the genre accordingly, like pop song, rock song, sad song, like romantic melody kind of song. That kind of stuff we get in any kind of song app. Okay, now coming down to photos. You get this feature here in case of any of the findings you may find, like in case of Google Photo, you get this finding, or you get this in your like inbuilt in your phone, like the person with similar face have got a similar folder where where only her pictures are there or his pictures are there with the same face. Okay, similar faces are grouped in that case in that website or in that folder. That is the basic case. Okay, so that is the major idea about clustering. Okay, now we will be going down with dimensionality reduction. So dimensionally reduction basically. So that is the concept that for that we use PCA that we will be understanding later. But here basically we need to understand sometime when the data is too big. Suppose my data set contains height, it contains weight, it contains age, it contains marks, it contains attendance, it contains sleep hour, all of it, right? All of this it's contained. So too many things actually confuses my model. So what we want to do, I want to keep only the most important information based on my problem statement. Okay, suppose like my problem statement is related to marks, right? In that case, I'll try to just avoid this uh, height, weight, age, this criteria because they are of no importance. The student marks is important, student attendance is important, and also sleeping hour is important because if the student like partially important is sleeping hour because based on the time the student is sleeping more like based on the time limit, of course not more than 8 hours a day. If the time limit of sleeping coming down within the 8 hour of range, that means the person is mind is fresh, and if the person has studied accordingly is able to get in through, right? So that is the major idea. So my most important criteria for marks perspective coming out, the features of marks and attendance, right? So I'll keep that and rest I will not keep. That is the major idea about the dimensionality reduction. Okay. So let's take an example about dimensionality reduction. Suppose a student, we have the maths marks, then we have the science marks, then we have the English mark. Okay. Now, instead of three numbers, we use the overall performance score. Okay. The same meaning, but lesser confusion. You get it? So here we have stored the maths marks separately, the science marks separately, the English marks separately. So here, suppose in that case, instead of taking three marks accordingly, three numbers separately, we are using the overall performance score of each of the students. Okay, in that case, the same meaning we will be getting at the end, but the confusion would be much less and we'll try to get the exact result. Okay, so now why reduction is important, that needs to be understood. Why reduction is important. Okay, so the reduction actually takes into the faster learning. Why it is taking the faster learning? Next, we have the lesser confusion, and of course, the better marks. Like marks in the sense, the visualization wise, the better visualization and also the accuracy would get better. Okay, okay, these are the major part of why we are choosing the reduction of dimensionality. Okay, so basically, these are all of the sections. So let's just recap all of it a bit, whatever we have studied till now. So unsupervised learning contains is the data like is the data that is given to the model without any proper label. the model try and understand try to find out the pattern inside it, and based on that, we are getting the details. Okay. Now, the model finds the pattern by itself and also uses the unlabeled data to take it further. Okay. And it finds the groups and also find the hidden pattern that is coming down for clustering. In clustering it does based on the similarity and the distance, and coming down with the uses of distance and the measure of similarity that we have already discussed how to do it. And finally, we have the bigger data that we need to just chop it off using based on only the important perspective. For that, we are using the dimensionality reduction. Okay. So hopefully things are clear to you up to now. Then we will be moving down in clustering part, specifically to clustering part, and we'll discuss about clustering and also see some of the part related to clustering. Okay. So coming down to clustering, we have discussed somewhat about clustering, and now we in a bigger way we will be understanding it. As I mentioned, like clustering is like making the groups of similar things. Okay. So how we can sort it accordingly? Suppose we have a basket fruit or like full of fruits that contains apple, banana, orange, and all of these fruits. Okay. Now we had to start sorting them, like only apples would be kept together, only bananas would be kept together, only orange would keep together. Actually, no one actually told to the model that like these are the different items, or there is no specific labels available. So the apples, the beside the picture of apple, it's not been mentioned that this is the apple. So we cannot, we don't have the we don't have the finding of the labels currently in case of unsupervised, right? So the clustering actually based on the key findings, and after finding the hidden patterns from the data, try to group the things together. Okay. So now we will be discussing what kind of things can be clustered. Okay. What kind of things can be clustered? Students by marks, customer by the shopping habits can be customer can be clustered based on that. Maybe the animals based on size and weight can be clustered. Song based on moods we can cluster. Movies based on genre we can cluster. So if these things can be measured, they can be clustered together. Okay. This is all about the clustering. So we have already discussed about the distance, like the distance in normal and also the distance in 2D that we have already have discussed. How many clusters are there? That would be the question, like based on the data, because my system doesn't understand the data, like doesn't understand the data because there is no labels, right? So it needs to find out like how many clusters should be there. That would be a question. Okay. Sometimes what it does, we decide the number of groups, and sometimes like give the idea that we want three clusters. I am giving down this data to my model, and based on that, my model is giving me three different clusters. Okay. But sometimes what happens based on the algorithm, my system or my model actually tries to find out what is the best possible number of clusters, and based on that it is going. Okay. So why do we need this clustering, right? That would be a major question up, because my data is big, messy, and confusing. But clustering, if I am clustering the data, it will help me to understand the data, find the pattern, and make the proper decision. That is the reason we are doing the clustering. Okay. So now we need to understand about types of clustering. Types of clustering, that means we have like different types of clusters. The very first one is center based clustering. Let me write it down. center-based clustering. Next, we have the hierarchical clustering. Next, we have the density-based clustering. Density-based clustering. So this is basically the three types of clustering. The very first one is center-based clustering. So each of the group or the cluster basically have a center. The things closer to the centers belong to that group, and the items or things that are out of the center that are taken in a different way. Okay, the basic idea about center based clustering is that, so we have the cluster centers for this, like basically the group centers or the cluster centers, whatever you want to take it. So we have the cluster centers and the things or the items that are closer to the center belong to that specific group. Okay, that is the idea about the center based clustering. Coming down to hierarchical clustering. Hierarchical clustering is like hierarchy, like the family tree, as you understand, right? The smaller groups actually combine into a bigger group. Like suppose if you are combining, like in case of hierarchical clustering, if I am taking, like suppose brothers, then we have the family, then we have the village. Okay, so this is the exact idea. This is the idea, like how it is going, like in a hierarchical form, it is going. Okay, so don't worry, we will be discussing each of them in details. Like it's just for you to at least have an idea about it when we will be going down and understanding the each of the models accordingly for that. So in that case, we will be understanding each of them in detail. Okay. Next, we have the density-based clustering. Dense means, of course, crowded. What is dense? Dense is the crowded. Okay, so it is based on the density. So the group where many points are packed together that are actually formed into a cluster. And some lonely points are there that are not a part of that very crowd. In that case, that points are actually ignored. Okay, so that is coming down to be the density based clustering. Okay. Now we need to understand what is outlier. So don't worry about what are the different forms of center-based clustering. We will be understanding about the hierarchical clustering. We will be understanding density-based. We will be also understanding. This is just the like normal lookout. When we will be going down in the models, we will be understanding each one of them in detail. Okay. Now we have to understand about outliers. Okay, so I guess we have already discussed about it, and you are well familiar with the term as outlier. Outlier is like the strange point, right? So the one that, like, suppose we have a uh, that one that is basically out of the group, like that is not coming to the range, that is considered as outlier. Okay, so you can think about one very tall student among all of the kids in a single class. That tall kid would be an outlier. Okay, so they actually don't fit into the range and actually they stays alone. So that is the case. Okay, so hope you understand about outliers. Next, we need to find out like good clustering versus bad clustering. So, what are the good cluster points and what are the bad cluster points that we need to understand? Okay, so good clustering versus bad clustering. Let me just write it down. Okay. So good clustering means groups are clear, points are close. Okay. Good clustering criteria. So the first point would be the groups are very much clear. And the second point is the points are close. Okay. Coming down to bad clustering. Coming down to bad clustering. Bad clustering is mixed groups. Like doesn't contain the groups are not clear. Then we are getting the mixed group. And the second one is the far points are together. Okay, so these are the example of good clustering versus bad clustering. Good clustering, as I mentioned you, that the group should be clear. All of the groups should be equally seen, and based on that, the groups point are also closer to each other, so that we can understand that the distance and based on the distance and the similarity. Okay, and coming down to the bad clustering, the groups we will be getting, like the clusters we will be getting, there the groups would be mixed. That means, suppose in mixed groups, suppose we have like in general, in actual, we have the data that is mixed. So we have two groups inside the data, in my data set, that is group one and group two. Group one is cold and group two is hot, like that. Okay. Now, in big groups contains the data point from both the clusters basically, okay, and forming a single cluster altogether. So that is a wrong grouping, okay. So that is the thing that we need to understand. Next, we need to understand, is clustering always perfect? That in that way we have to get the answer that of course not. The clusterings are always not perfect because that depends on the problem. Problem is wrong numbers in the clusters. Then we have, if we have the noisy data, if we have the overlapping groups, so that's okay, basically. Okay. So clustering is about finding the pattern, not the perfection, to be very precise. Okay. So if you are not getting the perfect cluster, that is good. That is okay, actually, not good. That is okay because this clusters actually depend on the data points, depends on the data set that you are choosing. Okay. So then there can be wrong numbers in the data. There can be messy data. You have not done a proper pre-processing of the data. The data can be noisy. There can be multiple outliers. There can be overlapping groups. Okay, so that needs to be taken care perfectly, and then we need to go ahead for the clustering. After taking care of all of this, if then also we are not getting the perfect cluster, that is fair enough, not a like a major problem. Okay. Now, basically, we need to understand each of them in details. Like, what is this cluster center? As I told you, right, we will be discussing about them in details, about cluster centers and details. So that we will be understanding now. The types of clustering. The first one is clusters, like the cluster center, like the center-based clustering, basically. Center-based clustering. So let's take an example. Okay. So before that, what is a center-based? Center means the middle point, and base, of course, it is dependent on. So center-based clustering means like we make a group using a middle point, and everything or every item that is near that middle point will be belong to that very group. That is the major idea about center based clustering. Okay, so in real life example, if we need to take, so suppose there are three class leaders standing, leader 1, leader 2, leader 3. So all of the students standing near the leader and close to him is like we can tell that each leaders become the centers of the group, and that are forming the center based clustering. Okay, so now what is center in the data? Okay, in real life, we discussed about the leader, right? So who is the leader in the data? What is the center point? So center point is the average point. Okay, center point means the average point. Center point means the average point. Now the center represents the middle of the group and the most typical point. Okay, that is the most typical point. So it is about the that average point would be the center of the cluster or of the group basically. Okay, now let's take an example. So suppose we have the height, like let's take the height of the students as 140. Then we have, okay, let's just align it here. Yes, 140, 142, 142. And next we are having 145. There are three students and the height of the student is this. Okay. Now we have to find out the average of it. And we need to take the average. So my average is 142. 0.33. Okay, so we'll take 142. So the middle average is around 142. So 142 becomes the center of this group. So any number that is close to this will be considered inside the same group. Okay, so these are the things. Hopefully you have understood it. Now, what are the points? In clusters, basically, each thing is exactly a point. Each thing or each item is exactly a point. One student is considered 1 point. One customer is considered as point. So this is the point. Okay. So now, how does the model use the center? That would be the idea. Okay. So the computer or whatever the model or the system, whatever you call, it actually picks up the center, checks which points are closest, and those close points are put inside one group, as I have mentioned you, right? So this is the idea about it. So this is my mean point or the average point. So any point that is coming near to it, so will be considered as the elements or the points of that very group. Okay. Now we have already understood about the distance, right? One dimensional distance, two dimensional distance, like the Euclidean distance, we have already discussed, right? So distance is of course the key here because distance means how far the point is from the center. Smaller distance means like belongs to this same group, and bigger distance means belong to another group, right? So that is the major criteria on. So how many centers do we need? That would be, of course, another important point. So we have to decide, do we need two centers, three centers, or five centers? More centers, like more groups, fewer center means fewer groups. So that needs to be taken in accordingly. Okay. So we can't take extremely large a number of centers that we can't take. So we need to take it in a form that it is not too big or not too small. But as I mentioned, more centers means more groups will be formed. Fewer center means fewer groups will be formed. Okay. So this is the idea about what we have already discussed. So now we will be just, this is the basic thing that we have already discussed, and we have like equally discussed each and every part of it. So we will be just taking it from here, and we have already discussed about the hierarchical clustering, as I mentioned, it goes like from brothers to family to village, like that it is going. And density based clustering, it depends on the density. Okay. And the center based, as I mentioned, that is we have to take the specific center. The center is coming down the average point. So any point that is close to the center, or the distance from the center to that point is closer, that will come down in a single group. Okay, so these are the types of clustering that we have already discussed in today's session. In the next session, we will be going from here, and eventually we'll take and discuss about the different models, like different models that are related to it one by one, and then finally we will be covering the density, like the dimensionality reduction part as well. Okay, so that things should be clear to you, and accordingly we can move ahead. Okay, so thank you guys for connecting in today's session. We will be continuing in the next session accordingly. Okay, thank you.